So here is the question that we are dealing with, a very common question, everyday stuff in the lab. A substance has a certain molecular mass, and in this case 124 gram per mole, and we need to find out how much of this substance we need to weigh in to make 0.25 liters of a certain molarity. Now the first question that we need to ask ourselves is, what is the unit of the thing that we are looking for? So we ask how much of this substance is needed. So we are looking for how much grams do we actually have to weigh in. Now let's write down the grams in the first place, the unit of what we are looking for. So this will be in grams. That's the first step. That is what we are looking for, and we want to make that absolutely sure that we don't lose track of that. The next step is we do a long line. Now, in the following step, we just simply look at what we have been given. So we have 124 grams per mole, we have 0.25 liters, and we have a 0.1 molar solution. We need to know that 0.1, that this unit, this molar, means actually mole per liter. So in the next step, we choose from these three givens, we choose one that contains the unit that we actually want, namely these grams here. We find that this is given in the 124 grams per mole. So what we do is we just simply write down the 124, and we always keep the units, gram per mole. We write it like that. So we have our first thing. Now we notice that we have the mole down here. So that will be our next step. What we do is we look around from our givens up here, this, this, and this, and we choose the one that contains the mole in it. It might contain other things, and the only one that contains moles in it is this 0.1 mole per liter. Now we write it in a way that this mole here and this mole here are on opposite sides. So a mole needs to be up here. So we write this as 0.1 mole per liter. And you see that the mole here and the mole here, the unit, are on opposite side. And I show you what this will do. Now, in the next step that we do is we say, okay, we have used this one, we have used this one, so all we need to do is we need to use this one here. We have a liter down here, sitting down here, and we do exactly the same thing that we've done before. We say, do we have a liter somewhere else from our givens? Yes, we have a liter here. Now we write this so that the liter is again on the opposite side. So we write this as 0.25 liters. And now we can do something really, really clever. We can cancel out our units. And we can say, okay, the mole here cancels against this mole, the liter cancels against this liter, and all we have left is 124 gram times 0.1, we don't have any units here left, times 0.25. And we just simply put that into a calculator and we get 3.1 gram for this. So that is the answer to our question. We need 3.1 gram of this substance to make up 0.25 liters of a 0.1 molar solution. I didn't use any equations or anything like that. I was just simply guided by these units. Here, gram per mole, liter, and mole per liter. And this then immediately gives me the right solution. So here's a slightly different question, and here we have the added issue that things are in different units. So for example, we have milliliter here, and we have millimolar solution here. But it should not be too difficult. So again, first of all, we need to ask ourselves, what are we looking for? What is the unit of the thing that we are looking for? And again, how much of this substance is needed? It tells us that we are looking for the amount of the substance, which usually is measured in grams. So let's put that down. Long line. And in the next step, we look at the things that we have given. So we have our molecular mass given here. We have 10 milliliter, that's the volume, and we have our molarity, we have the concentration of this solution that we want. So first of all, we make sure that we have the grams that we are looking for. We find that in our givens, and we see that it is given in the molecular mass. So we just simply write it in such a way that the grams are on top of the line. So we have 554 grams per mole. So that's the first thing. Now we need to look for something where we have the mole that we have down here, where we have mole in the unit, and we find that we have this here because if we can write 20 millimolar, we can write this as 20 times 10 to the minus 3 mole per liter. And what we see is that we have a mole here, so we write it in such a way that this mole here and this mole here cancel each other out. So we write it so that the mole is on the different side. So we have 20 times 10 to the minus 3 mole per liter. And now eventually we are looking for something with liter in it, and we have here these 10 milliliters, but again we need to be careful. Here we have milliliters, here we have liters, so we need to convert the milliliter, and we know that 10 milliliter equals 10 times 10 to the minus 3 liter. Milli 10 to the minus 3. So all we need to do is we need to write it in such a way that the liter here, which is down here, will find its equivalent up here. So we put these liters up here. So we have 10 times 10 to the minus 3 liters. Probably should do it like that. So what we can do now is we can again cancel our units. So the gram stays, but we can cancel the mole. We have mole cancels against this, liter cancels against this, and what's left is we have 554 gram times 20 times 10 to the minus 3, no units because the units have cancelled out, times 10 times 10 to the minus 3. Again, the units cancel out. And if we put that into a calculator, we get equals 0.111 gram. So again, by just being guided by the units of the givens that we have, gram per mole, milliliter and millimolar, and converting these millis into the standard units, like here, we are guided. We don't need any equation or anything like that. We just arrange our units in such a way that things cancel out, and we can very easily calculate how much of the substance we have to weigh in.